Hey everyone, welcome to the Math 6 7.5 video. Today we're talking about writing and graphing inequalities. Alright, so what's an inequality? Well, an inequality is a mathematical sentence that compares expressions, and it contains the following symbols. So we have the greater than symbol, okay, opening to the left. Sometimes we say is more than. That's a phrase that can go along with that sign. We have less than, okay? I like to remember less than is pointing that direction, because if you take, that and you just kind of spin it, if I can get it, there, kind of creates an L, right? Okay. And if we say is fewer than, we're kind of getting at less than. Greater than or equal to is just like the greater, but it has this little sign under it, okay? And that means greater than or equal to. And is at least or is no less than, a lot of times kind of come along with that sign. And then less than or equal to, and then we have is at most, and is no more than, okay? A lot of times comes along with that. All right, so one skill we need to have is writing inequalities, okay? We need to be able to take a sentence and write it as an inequality. So let's see the first one here. A number C is less than -4, okay? You might be thinking that one's pretty easy, and you'd be right, okay? A number C, okay, is, remember we said is means equals, right? But now it's is less than, so is less than, and then less than what? -4. That's all you have to do, okay? How about this one? The sum of a number in B, or a number B and 7 is greater than 8, okay? Well, so the sum is the first thing we see. The sum of what? A number B and 7, so B is going to go there, and 7 is greater than 8, so greater than opens to the left, and you get an 8. All right, the quotient of a number K and 6 is at least 7. So this one we had to do a little more thinking on, maybe. So again, quotient means division, right? And remember, we write division as a fraction bar. So the quotient of a number K and 6, okay, is at least. So this thing is at least 7. So I'll put the 7 there. At least 7. So this thing, could it be more than 7? Could it be less than 7? Could it be 7? Well, this thing needs to be at least 7. So to me, that says greater than or equal to, okay? K over 6 is at least 7, or K over 7 is greater than or equal to 7. It could be greater than 7 or equal to, but at the very minimum, or at least, this thing has to be 7. If you go back up here, okay, at least, let's find the phrase at least, boom, right there, right? Okay. All right, lastly, 88 is at least the product of a number and 8. Okay, so 88 is, so that's what we're seeing first. Again, we said at least greater than or equal to. Well, what? The product of a number and 8. So product means multiply, and we're multiplying what? Some number. Do they say, it just says a number. It doesn't say a number K, a number Y. So we can use whatever variable. Let's use T and 8. So 88 is greater than or equal to T times 8. All right, so quickly, let's talk about solutions to inequalities, okay? So we remember that solutions turn equations into true statements, right? Okay, so like, for example, is 7 a solution of D plus 8 equals 15? If it is, it will turn this equation into a true statement. So we take that 7 and we put that there, right? So is 7 plus 8 equal to 15? Put a little question mark there. Well, 7 plus 8 is 15, and last time I checked, 15 equals 15, right? That is a true statement. So 7 is a solution because it turned our equation into a true statement. So what we end up doing with inequalities is practically the exact same thing. So what I did is I kind of drew a chart here, and we're going to kind of fill this chart out. So I gave you different values for x. We're going to call x 7, then -2, and then 0. And what we're going to do is we're going to plug them in to this equation each different time, and we're going to say, is it a solution? Okay, remember, a solution produces a true statement. So let's see, x plus 3 less than 7. Let's test. Is 7 plus 3 less than or equal to 7? Well, what's 7 plus 3? 10. Is 10 less than or equal to 7? Ooh, 10 less than or equal to 7. No, 10 is greater than 7, right? So is the given value a solution? No, not a solution. Let's try -2 though. All right. negative 2 plus 3, is that less than or equal to 7? Well, what's negative 2 plus 3? That'd be positive 1. Is positive 1 less than or equal to 7? Yes, that one is. And then this last one was 0. Is 0 plus 3 less than or equal to 7? Well, what's 0 plus 3? Not 0, that's times. 3 less than or equal to 7. Is 3 less than or equal to 7? Yes. So again, that is a solution, that is a solution, that is not a solution. All right, so now we need to talk about graphing inequalities. Okay, so when we're graphing inequalities, we end up doing a little bit more than if we just graph a number. Okay, so if we're going to graph x is greater than 3, how would we do that? Okay, well, if we're just kind of doing this in our homework and we're just given blank graph paper and we just have to graph one thing, what I'd like you to do is this. Put that 3 in the middle and then give me a couple numbers on either side. So 4, 5, 6, 7, and then 2, 1, 0, and then negative 1, okay? So now we're graphing x is greater than 3. So what does that mean? Well, it means all numbers that are greater than 3 need to be graphed, okay? But when it's greater than or it's less than, we use what's called an open circle. If it's greater than or equal to or less than or equal to, we use what's called a closed circle. So in this case, it's x is greater than 3. So I'm going to find 3, and I'm going to circle it with an open circle, but I'm not going to shade that circle in. Why? Because I want to graph all numbers that are greater than 3. I don't actually want to include the number 3. So that's why I don't fill it in. And then I shade to the right because that's where numbers that are greater than 3 are located, such as 5 and 7 and 100. That's way down that way. All right, let's do another. Let's graph m is less than or equal to 4. Again, the variable stands for all numbers that are less than or equal to negative 4. So again, give the given or graph the given number in the middle-ish, okay? And then a couple on either side, so negative 4. So to the right be negative 3, negative 2, negative 1, 0, and this way be negative 5, negative 6, negative 7, negative 8, negative 9, negative 10. And let's ask ourselves, okay, well, first of all, m is less than or equal to negative 4. So negative 4, where's negative 4? Oh, it's right there. And again, remember, when it's greater than or equal to or less than or equal to, we do a filled-in circle. So let's find negative 4 and do a filled-in circle. And then we're going to shade, what direction? Well, we need to include all numbers that are less than negative 4. So numbers that are less than negative 4 are going to be this way, right? Okay, negative 6, negative 5, negative 7, negative 8, negative 9, negative 10. So we're going to shade like this to include all of those. All right, so a little word problem here. The NASA Solar Probe Plus can withstand temperatures of up to and including 2600 or 2600 degrees Fahrenheit. We're going to write and graph an inequality that represents the temperatures that the probe can withstand. Okay. All right, so let's think about it real quick. Probe plus can withstand temperatures up to and including 2600 degrees. So we're going to write an inequality and then we're going to graph it. So if we're writing that, let's think about it. What about the temperatures? Well, it can be 2600 degrees. Can it be more? No, because it says up to, but it could be below, right? So to me, that says the temperatures it can withstand are less than or equal to 2600 or 2600. Let's just make sure, yeah, the temperatures that it can withstand are less than or equal to 2600. Yeah, that makes sense, okay. And including, so we needed to have the equals part, right? Okay, so now we've written it out. Let's graph that inequality. So here's my 2600. Again, it's a less than or equal to, so it's a filled in circle. And I'm going to shade to the left, okay, because that's where the temperatures are that are less than or equal to 2600, such as 2500, 2400. And so we just shade down that way. All right, can you guess what the photo is? It's like one of those zoom in things. Can you guess? No? What about now? What about now? Now? Well, you guessed it right. It's a man getting attacked by a deer. Duh, I'm sure we all knew that. So yeah, it is. That looks rather unfortunate. But deer hunting can be very dangerous. Sometimes the animal doesn't exactly want to be hunted. So let's say, though, you, despite the danger, you're going to go anyway. And you plan to go deer hunting, and you are allowed to bring home up to 4 bucks, okay? But each must be a 6-point buck or greater. So what's a 6-point buck? Well, point, guys, is just really referring to the number of antler, they call them tines or protrusions, little mini antlers off the antlers that are on the head of an adult male deer, okay? So each one that you bring home must have 6 or more little tines, okay, or 6 or more points. So we're going to write and graph an inequality that represents the number of bucks that you can bring home from your hunt, okay? And then we'll do another one, but let's focus on this one first. So let's write it first. Inequality that represents the number of bucks you can bring home. Okay, the number of bucks. So not talking about the antlers, the tines, or the points, right? Just the bucks. Well, you are allowed to bring home up to 4. So could I bring home 1? Yeah. Could I bring home none? Yeah. Right. I could not get anything. Could I bring home 4? Yeah. What about 2? Yeah. 3? Yeah. So how do we write that as an inequality? I would write the number of bucks I can get has to be less than or equal to, because I can't get more than 4, but I could get up to 4. Okay, including 0, 1, 2, and 3, and then 4. Okay, now let's graph that. How do we graph that? Again, you're going to write a little inequality line, and if you're not given it ahead of time again, just give yourself a few tick marks, put your number somewhere in the middle, and then do 3, 2, 1, and then 5 and 6, and then say, okay, b is less than or equal to 4, so my 4 is there, it's a less than or equal to, so I fill it in, and then I shade down this way, and there we go. Okay, now let's do it this way. Or this one, write and graph an inequality that represents the points on a buck you are allowed to bring home. So on a buck, okay, a bucks, we're referring to 1 at a time. Each must be a 6-point buck or greater. So that represents the points, okay, so maybe P for our variable. And the points need to be, well, 6 or greater. So 6 would work, right? 7, 8, 9, right? So it's like 6 and up. So maybe the points need to be greater than or equal to 6. And the reason they want you to do that and not get something less than 6 is because they don't want, really young deer to be killed. They want mature, older deer to be hunted. So that's our inequality. And then the last thing we need to do, make our 6, 5, 4, 3, 7, 8. Again, I'm including the 6, so I graph, circle, and fill it in, and I shade to the right, greater than or equal to. All right, y'all, that's all I got. Thanks for sticking with it. I will see you in class, and we'll talk more about inequalities.